So yesterday, you guys kind of said it was a pretty easy assignment. You just plug it in, not really a big deal. We're doing a little bit more of that today. We've got some, we have a function right here. It's asking about the limit of that function. And then you're going to see in your textbook on your assignment something that looks like this. It wants the simpler function that agrees with f of x at all but one point. And you're going to go, I don't know how to do that. You do know how to do that. If it agrees with this function at all but one point, what's going to happen at probably one point on this thing right here? What's there going to be? There's going to be a hole. So it's talking about the same function but not the hole. How do I write the same function without the hole? Factor and then, yeah, reduce. So let's factor this thing. If I factor the top, goodness, if I factor the top, we take out an x. Whoops, and we have 1 minus x. Sorry about that. No, we don't. Goodness gracious. Thank you. X minus 1. On the bottom, we have x. The x's cancel. And that leaves us with, they're saying, well, actually, they just want you to take the function and do it. I probably shouldn't have done the limit yet. Sorry. So the function that's left that we're actually finding the limit of is x minus 1. So the answer you would put for that part of the question would be x minus 1. It's a line, it's got a hole in it. So then they want to know what's the limit as x approaches 0. And from yesterday, we know we just take it and plug it in now. So 0 minus 1 is -1 is our answer. Questions on that top part? Does everybody kind of see what it's asking for over here? It wants the function after you factor and reduce. Let's look at the next one. We know we're supposed to factor and reduce. Do you guys remember how to factor those? Difference of two perfect cubes? I reminded you maybe yesterday or the day before. I'm going to do it again. And after this, if it shows up on a quiz, I'm not going to feel bad. Got it? Here we go. Difference of two perfect cubes. You have a short set of parentheses and a long set of parentheses. The signs, what do you do with the signs? How do you know what they are? So same, opposite, a positive. Take the cube root of the first term and put it in the front. The cube root of the last term and stick it in the back. Square the first term, stick it in the front, so x squared. Square the last term, stick it in the back, so that's 4. Take the first term times the last term and stick it in the middle, so 2 times x. Zoom in so you can see that a little bit better. So that's what that looks like factored. We reduce, so we take out x minus 2. And now I'm looking for the limit as x approaches 2 for x squared plus 2x plus 4. Now we plug it in. 2 squared is 4. Plus 2 times 2, which is 4, plus 4 is 12. Everybody okay? Okay, these notes, I don't want them to take forever. I think, especially after yesterday, I'd say with confidence most of you in here can do this one and we could skip it. Is that true? Yes. Are you sure? I'm happy to do it. Can I go on? All right, then we have something called the rationalizing technique. Now, what's weird about this for you probably right now is you're like, okay, well, I don't see the problem. I know she's talking about rationalizing, and I see square roots, but they're on the top, so what's the big beef? What's the problem? The problem is that you can't reduce anything, and you know you have to, because it's saying find x, or it's saying find the limit at 0, and if you go to plug 0 in, we've got a problem. So you're going to use that same rationalizing technique to get the square root off the bottom to get rid of the square root totally. So we're going to multiply by, do you remember what these things are called? The conjugate. It's where you take the two terms and you change the middle sign. And this is perfectly legal to multiply by this because you're multiplying by a dressed up version of 1. Anything over itself is 1, so this is perfectly legal. So now we're finding the limit of this whole thing. the top it looks pretty scary. You're going to have to FOIL that. I know, right? But this is the beauty of this. It's actually going to go really fast, and this is why you chose the conjugate. Because the outer and the inner terms are going to cancel anyway. So all you're concerned with is squaring the first term and squaring the last term and putting a minus sign between them. Because what we have here is the difference of two perfect squares. So if I square this first term, what do I get? Yeah, the roof pops off, and I have x plus 5. How about the last guy? It's a 5, right? And there's a minus sign between them. On the bottom, I'm going to leave the x here, and I'm not going to distribute it. I think you're going to see why here in a second. You don't want to distribute on the bottom. You'll make more work for yourself. What happens on the top? The 5's go away, because 5 minus 5 is nothing. So I have x over x times some stuff. Now what can you do? Yeah, now you can reduce. We can cancel out our x. So now what we have left is the limit as x approaches 0 for 1 over, that's not a 0 on the top. Factoring is dividing, remember? So when you divide anything by itself, it's a 1. Don't you dare put a 0 up there. It's 1 over the square root of x plus 5, the quantity, plus radical 5. Now you can plug in 0. We plug in 0. 0 plus 5 is radical 5. So on the bottom, I'm going to have 2 radical 5s. Can I leave it like that? Oh, wait. We have to rationalize again. Bummer. Not that hard, though. What do I multiply by? Yeah, radical 5 over radical 5. It's not a big deal. Radical 5 on the top. The bottom becomes what? 10. Ocean, how'd you get it? Correct answer. It's more specifically, Ocean, how do you get that? Very good. So radical 5 times radical 5 is 5. 2 times 5 is 10. Here's our actual answer for that limit. Questions? I know it's some extra work, but this is all stuff you've seen before. Like, this is not that big of a difference in what we've already done. Do you need more time to write that, or can we move on? All right. I want everybody to try this one by themselves. But I'm going to keep talking for those of you that need it. So try to move ahead and tune me out. But I'm going to keep talking in case you need it. If I put a 0 in the bottom, it looks like it's going to be fine. So we substitute. 0 plus 5 is radical 5. Minus 3 over 0 minus 4 is negative 4. Wait, did I type this problem wrong? Did I say wrong? Well, we only need to do the conjugate thing if we need to reduce, or if we need to factor. And with the problem I wrote down, we don't need to factor. So I'm looking at my notes from last night to see if I wrote the problem wrong. I think we're supposed to. Hang on. Oh, the limit. The limit's supposed to be 11. Can you guys change that? Sorry. We're approaching 11. I should have changed that. I should have caught that. So if we put in 11, let's try this again. 11 plus 5 is 16. The square root of 16 is 4, and 4 minus 3 is 1. 11 minus 4 is 7, so I guess we just get a 7th. Did I do it? So it's 11, x plus 5 minus 3, x minus 4. Yeah, when we plugged it in, it worked, right? Yeah, so that's it. Okay, let me back up. Great question. Thank you, Ocean. He made the point that I wanted to hear. Here's the thing. If the limit was 4 and you plugged it in, the bottom would be a 0, which means you've got some more work to do. You're going to have to factor and reduce or rationalize it or whatever. In this case, we don't have to. If you take that 11 and you plug it in, we get an actual value. That is the limit. Does that make sense to everybody? So sometimes you're not really going to have to do much work, and that's okay. Okay, let's move on. I think, here's another example. Let's look at this one. Let me make sure I wrote the problem right. I didn't. Make this limit of 5. Sorry. It was like 11:45 when I typed these. I apologize. So on the back side, this time the limit as x approaches 5. Am I going to be able to just substitute in? No, because it's going to make the bottom a 0, and that's a problem. So now we have to rationalize. So this is where I'm going to start talking, and hopefully you can just work ahead without me. You need to multiply by the conjugate to get rid of the square roots. So we say, okay, I need to multiply by radical x plus 4 plus 3. Remember, you change that middle sign or it won't work. When I FOIL across the top, I'm going to get, you're supposed to rewrite limits. I'm not going to be a huge stickler if you don't. Just know that your professor might really, really, really want you to. You're supposed to. Okay, square the beginning, square the first terms, and I get x plus 4. Square the last term, and I get a 9, and those are minus signs between those. And then on the bottom, I am not going to FOIL, because my hope is to kind of make this bottom piece go away. I need that bottom piece to go away so that it will be something that I can actually substitute in. So leave this guy alone and just write them next to each other. On the top, 4 minus 5, or 4 minus 9 is negative 5. So on the top, I actually have x minus 5. That's good news because I need those guys to cancel. So now I have the limit as x approaches 5 for 1 over the square root of x plus 4, the quantity, plus 3. And now you can just substitute. So if I put a 5 in here, I've got 1 over radical of 5 plus 4. So I have radical 9, bless you, plus 3. So I have 3 plus 3, which is 6, and I get a 6. Okay, how did we do? You guys that kind of did it all by yourself, was anybody also able to get 1/6? Good. Are there any questions about anything I've written down on the board? Anything I can explain better? Great, I'm amazing. I love that. All right, let's move on. Next one. And I'm going to start checking these to make sure the limits are correct on these. Yeah, I think a lot of them are. But last night, like, I didn't want to keep typing the limit part over and over, so I copied and pasted, and then I forgot to go fix the limit. Okay, this one is 0. We're good. And we know that because, you know, obviously you're not going to be able to plug it in, which is the whole point of today, so learn how to get it so you can plug it in. And this looks pretty insane. And some of them will look insane. And yes, you do have to find common denominators, and it's really not that bad. So when we look at this, on the top, we're going to have some common denominators. One denominator is 3 plus x, the other one is just a plain old 3. You're going to have both on the bottom. 3 times 3 plus x. Whatever you did to get the bottom, you have to do to the top. The guy on the left is 3 plus x, which I have, but I also multiplied by a 3, so I'm going to have to multiply by a 3. 3 times 1 is 3. Minus, on the right, I had a 3 on the bottom. Now I have a 3 plus x. So I need to multiply the top by 3 plus x, the quantity. Why did I rewrite it in parentheses? Did I have to? Why? The negative. It's the quantity, exactly. And that is the easiest mistake to make, is that you won't carry that negative through. So be careful. And so let's keep going. Let's keep simplifying. On the top, 3 minus 3 is nothing, so now I just have x over 3 times 3 plus x. Now you're dividing by x over 1. Remember that little cutesy phrase I taught you? When dividing fractions, don't ask why, flip the second one over and multiply. What? Because this is the negative x that your teacher just left off. For that reason right there, because I just made the mistake. Thank you. Good catch. I just said that. I'm terrible. All right, so when dividing fractions, that's why flip the bottom one over and multiply. Now what can we do? You should see something that's really great that you can do. Cancel the x's, right? Now that doesn't make that negative go away. There's still a -1 right there. So now I'm looking for the limit as x approaches 0 for -1 over 3 times 3 plus x. Plug in your 0, and we get -1/9. Really wasn't that bad. Any questions? Everybody okay? Can I do it? Yes, totally. You guys need more time? All right, the next one. What should we do on the next one? Does this one look a little crazy?
Yes.
Yeah, it totally does. That triangle, guys, is called a delta. You've seen that before in your table set function in your calculator. Delta usually stands for change. Don't stress too much about it now. We are going to treat x as one name, one variable, and the delta x as a completely separate name and variable. It's like, this is Jeff, this is John. Two totally different variables. If that triangle still freaks you out, you can replace all of your delta x's with h's. We'll talk about later why it's h's. They like to use h for that. So we're going to replace those with h's for the first time just so you guys can kind of see it. So we are going to rewrite this as the limit as x approaches 0 for 2 times x plus h minus 2x all over h. You do have two variables going on here, and that's okay. And your notes, yep, fix this. Sorry, don't hate me. I tried to type most of them for you. That should be delta x towards 0. So it does matter what variable is down here underneath the limit when it's asking the question. It's not saying as x approaches 0, it's saying as delta x approaches 0, or in other words, h in this case, because we've just changed it to be an h. So if I put a 0 in, obviously we're going to have a problem. We have an h on the bottom, so we know we need to do some extra work to kind of fix this thing up. But it's not going to be bad. Let's simplify the top and see if we can kind of get us down to something. What do you want to do on the top? Yeah, I think distributing is a wise move. Let's do that. So if we distribute on the top, we get 2x plus 2h minus 2x. And what do you notice happens? Yeah, 2x minus 2x, that goes away. So now I have 2h over h, and then what happens? The h's cancel. So what do I have left? 2. So the question is asking, what is the limit as h approaches 0 for the constant 2? Do you remember yesterday what you do about constants? What's the answer? 2. Just going to approach 2 every time. Ta-da! That wasn't that bad. Don't let the triangle freak you out. But I think we're going to talk about those delta x's next week, I'm pretty sure. Alrighty, next one. This one looks a little bit insane, doesn't it? Just for kicks, let's leave the delta x in just to kind of see what happens. And also, I did screw up on this one too. This is delta x approaches 0. My bad. Like I said, I just kept hitting control paste, and I literally got the same limit. Okay, so I think basically this one you just need to be a strong algebra student. Obviously, I can't plug in 0 for delta x everywhere because we're going to have a 0 on the bottom, and that's a problem. So this first piece right here, squaring, don't you dare say that that's x squared plus delta x squared. What's wrong with that? Have to FOIL. Here's the shortcut on foiling. For you, it's going to create a perfect square trinomial. Square the front guy, square the back guy. The middle one is going to be, you steal the sign. The middle one is first times last times 2. So I have 2x delta x. Remember, those are two different variables. So that's that one foiled. What do you guys want to do about this piece right here? Distribute. So now I have minus 2x plus, whoops, just kidding, minus, my bad, minus 2 delta x plus 1. What do I do in this last piece? Yeah, distribute the negative. So I have minus x squared plus 2x minus 1. And the whole thing is over delta x. I know you guys thought it was nuts when we started putting letters in math, and now we're putting in shapes. We're just going to see how many things we can throw at you guys. Okay, on the top, does anything interesting happen at all? Yeah, x squared minus x squared, so that goes away. Negative 2x and positive 2x, that goes away. Positive 1 and negative 1, that goes away. Anything else? I think that's it. Let's rewrite it so it doesn't look crazy. So we've got 2x delta x plus delta x squared minus 2 delta x all over delta x. Is there anything we can do? Yay! Bree is right. Remember, delta x is like one variable. And this guy has one, and this guy has a couple, and this guy has one, and we have one on the bottom. Whatever you do to one part, you have to do to all the parts. So, take one out, take one out, take one out, and this guy, we take one out. So what we're left with is 2x plus delta x, and this entire time we're supposed to be rewriting this. Limit as delta x approaches 0. What's your last step? We're getting there. Did you mean this too? I don't know, I left it out. Sorry. Good one. Thank you. Sorry. Anything else I forgot? I don't know. Okay. What's the last step? What do we need to do? Plug it in. Take 0 and plug it in where? Only for delta x, not for x. So when we do that, we get 2x plus nothing minus 2. And yes, that's the answer, and yes, it has a variable in it, and yes, sometimes that's okay. Everybody okay with that? Because it needs to be. So delta x, the change in x, is going to approach 2x minus 2. Questions on that one? Yeah, here we go. Here's some work for you. There are two special limits that you have to memorize. Grab your calculator. Type this little guy in. And find out what is the limit as x approaches 0. Make sure you're in radians. What does x approach? I mean, as it approaches 0, what do we get? 1. Thank you. Try the other one. As x approaches 0, what do we get? 0. So, take a second. We need to memorize these. This is sine x over x. That could say sine delta x over delta x. It could say sine of k over k. Those variables just have to match, and if they do, then it's 1. Then we have 1 minus cosine of x. Notice it's not cosine of x minus 1. 1 minus cosine of x over x is 0. Keep those in mind, and let's scooch down and look at our examples. As I look at this one, I think that is almost something I already know. It kind of looks like sine x over x. Problem is that there's a 5 on the bottom. I would love to do something so I could cancel and kind of get rid of that 5 or the x or something. Or maybe I should split it apart. Does this also mean this. Do those two mean the same thing? Yeah, they totally do. And based on the properties we talked about yesterday, what you can do here is, because you're taking the limit of this whole thing, you can take, and you don't have to write this on your assignment, but I put it on your notes. To find it, you could say 1/5 times the limit as x approaches 0 for sine x over x. That's totally legal. That's a rule we learned yesterday. You're allowed to do that. And this is one we just memorized. It equals 1. So we say 1/5 times 1 equals 1/5, and we're done. How we doing? Everybody okay? All right, can I move on? Next one. I'm seeing sine x over kind of an x, and I'm seeing 1 minus cosine over kind of an x. What do we do? Split it. So what I really have here is I could have sine of x over x times 1 minus cosine of x over x, and take the limit of the whole thing. Based on yesterday's rules, you're totally allowed to do that, and you can take the limit of the first one, which we know now is 1, times the limit of the second one, which we know is 0, and we get 0. It's not bad, right? You guys try the third one on your own. Should have wrote that in a different order, sorry. Here, that's going to bug you guys. It's probably going to bug me. Most of you probably got this far. You were like, well, I know I can make this a half, but I still have this problem. Those variables don't match. I really, really want them to. What would be helpful if we could stick on the bottom? A 3, right? That would make it 3x over 3x, which means we could figure this thing out. So let's just do this, times, I need a 3 on the bottom, put a 3 on top, and why is that legal? Because you're multiplying by 1. So, if I rearrange this, and I'm going to do that because this is our notes, I have 1/2 times sine of 3x over 3x times 3. That's what I have now. I took this 3, multiplied those together, shoved it under the bottom of that one. And now we can finish out the limit. Those two variables match. So now I can say that limit right there, we have memorized, it's 1. And I'm multiplying by a regular old 3 and a regular old 1/2. So we get 3 halves.
I think I'll just start with 3 halves.
No. And I'm glad you asked. Because sine of 3x does not equal 3 times sine of x. Sorry. Great question. And this is why. So you cannot start out with 3 halves. It was a coincidence that it turned out that way for you. Does that make sense to everybody? These mean two different things. This is sine of 3 times x. This is 3 times sine of x. Great question. This last one here, we did one like that already. Do you guys want to try it, or do you feel okay? I'll tell you what. The answer is -1/4. You want to work on it, I'll come around. You can ask questions if you need to. The rest of you guys can get started on your assignment. It's already written on your notes.